Okay, so now we're ready to talk about conditional expectation. So we can start with a definition here because we're working with conditional situation. For the discrete case, the conditional PMF, we know the notation that we've been using in the past is you're looking at PMF x given y, right? So you're looking at the conditional density, or sorry, conditional function, probably mass function, given y equals to y about x. So we know that will be the ratio of the joint over the margin of y. So if you're going to focus on the conditional expectation of x, because y is being conditioned, the random variable here is x. So what you do is you simply focus on the values of x, right? The values it can take, and then the conditional PMF that you know, PMF that you know, and then sum over all of the possible values of x. Okay, so the expectation still follows what we learned before, but now everything is focused on the conditional expectation of x because that's the only random variable here. Similarly, we define that for the discrete case and make sure that we need to have the density, the marginal density PDF of y is greater than 0. So you have this conditional PDF defined to be the ratio of the joint over the marginal. And then the expectation of x given y will be, well, the values of x multiplied with the density, conditional density, and then it's an integral with respect to x. If you're curious about those properties that we saw before, about expectations, they're actually going to remain as well. So for example, if you're working with a function of a random variable, gx of x, then the conditional expectation of gx given y will be very similar to what we just see before. Gx is the function itself, and then you multiply with the conditional PMF of x given y, summing over all possible x for the discrete case. And then similarly for the continuous case, it's a multiplication of the gx function with the conditional PDF, and then you do an integral. Lastly, we can see the expectation of sum of random variables. This also follows of what we did before. If you are conditioning on y and you're looking at sum of xi, then it becomes the sum of the conditional expectation of each of the xi. So to help you to think about all of this, it might be useful to think about the condition y, capital Y equals to small y, as taking expectation of x on a reduced sample space. So in the past, it was just going to be the conditional, so y can be anything. But here we're looking at conditional distribution, and now expectation of y given y, you can just focus on a reduced sample space of y equals small y, and then that will be the reduced sample space that you work with, and that's why all of the properties and the results that we saw about expectation are going to remain when we are working with conditional expectation.